Hi class, it's my first attempt at a video, so I thought we would try a problem from the latest module, Module 8, so I can give you an example of how to solve for some of the formulas that are presented in that chapter. So this is again Chapter 28 from Module 8, and this is problem number 5, so 28-5 from your textbook on page 639 for your own reference. So I've recreated the table here with the information given in the problem. So the problem says, the following table depicts the product market and labor market a digital device manufacturer faces. So here we have different labor schedules, 10 workers per day, 11 workers per day, 12 workers per day, so on. How much output altogether they produce as you increase the number of workers you have, and also the price of the product that you'll get as you increase your output. So clearly we're not dealing with a firm that's selling in a perfectly competitive market. If they were a perfectly competitive market, they wouldn't be able to influence the price. So clearly they're in some other kind of market form, like monopolistic competition, for example, would probably be the most likely, or monopoly. So we have all this data here, and the question asks us first to calculate the firm's marginal physical product, total revenue, and marginal revenue product at each level above 10 units. So they say above 10 units because these are going to be marginal amounts. So because we don't know what comes before 10, we won't be able to get the difference coming up to 10. So we'll start with 11. And at number 11, at level 11, the marginal physical product, all that asks is how much that 11th worker adds to the total production. So what you're going to have here, so I'll write it out here for you. MPP, marginal physical product, is just equal to the change in output over the change in labor. Now, often what we find is that the denominator, the change in labor, with a lot of these formulas is always just going to be 1. We're just increasing by 1 worker, so we're going to be dividing by 1. It's not going to really change it. So what we're really going to focus on here is the change in output. It'll always be divided by 1, so it won't change. So as we go from 10 to 11 workers, we go from 100 to 109 units. Total physical product is just another way to say output. So in output, let me get my green marker for you, so you'll see the answers versus the data that's given. So the additional marginal product is, the marginal physical product is 9 units. The 11th worker basically increased total production by 9 units. We keep going, 109 to 116, 7 units, keep going further, 5 units, so on and so forth. You're just doing the math and dividing by 1. You're just subtracting one from the next, dividing by 1. We're only increasing by 1 worker. And then 1. So as you can see, each additional worker that you add isn't adding as much to the total, which is a concept we have been introduced to before. So that is our total physical product. So now we're going to find the total revenue. Now, revenue, simply price times output. Okay, different than profit because we don't subtract our costs. This is just how much money is coming in before we take into consideration costs, which we don't have here. So I'm just going to write this down here just for review. Very simple. Price times output. And again, for this table, they're calling output total physical product. Just another microeconomic way to say it. So I've got my math all done out here. Pardon me. So the total revenue here, might as well fill it in, is $5,000. We're just multiplying 100 units times $50. All right, we're going to keep going across. This is 5,341. Multiply here, $48 times 116. We are getting 5,568. Excuse my awful handwriting. And just going down the line. Again, we're just plugging in the price and quantity at each different level and seeing what we get. Sorry, that's really atrocious, huh? Last one, 5,625. Now, they don't ask us about this, but you'll notice that it does increase for a while, up until 14 workers making 124 units. But then it gets to a point where it actually starts decreasing because you have to sell your product at a lower price to sell up to 125 units. You actually start to lose money because all of those previous 124 units, now you're taking $1 off them to sell them at a cheaper price. So you can see that kind of, if we were to graph, this would be like a bell curve going up, 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 and then coming down again. All right, and lastly in the table, they ask us to fill in marginal revenue product. So again, it's kind of maybe sounds like a confusing term, marginal revenue product. What does that mean? But again, marginal just means change in, just at the edge. When you go from one spot to the next, what's changing. So marginal revenue product here is just going to be the change in revenue for that amount of output. So for the given output, you're going from 100 to 109. How much more money do you make? You sold it for a cheaper price, but you're also selling more. So what's the difference? So in this case, you're just going to simply subtract your revenues one from the next, just like we did with the marginal physical product. So in this case, it would be $341. If we do the subtraction here, how much more revenue do we get going from 109 units of revenue to 116 units? I'm not going to bore you with the subtraction, so I'm just going to fill this in. 227, I'll try to write big so you guys can see that. This is 119, 17, and negative 79. So again, this shows us what I was saying to you before, that kind of bell curve. It starts to go up and then it goes down. We see the marginal product, it's increased, we're getting more every time up until this point, but not that much more. So it's going up, we're adding more revenue, but not so much. This time we only added $227. This time we only added $119. And then it gets to a point where we start going down, we're losing revenue. We lost $79 to sell 125 units. So we filled in our table. The next part of the question asks, the firm competes in a perfectly competitive labor market, and the market wage it faces is $100 per worker per day. How many workers will the profit maximizing employer hire? Now, since this is the only information they give us, we're going to assume no other variable costs. We're just going to think about the labor as the variable cost for this. So that just simplifies it a little bit for us. So if the wage is $100 per day. Works out, we have our workers per day. So this is basically going to be our marginal cost. It's a constant marginal cost. It doesn't change because no matter how many workers they hire, they're always going to pay them $100 a day. So I'm just going to write down here that in this case, this equals our marginal cost. Now, we know that we want our marginal revenue to equal our marginal cost. So at $100 a day, the only place we'll find that will go up to that is if we stay here, we're paying $100 per worker, but that worker is bringing in an additional $341. So we can keep producing. At $227, the same thing. We can keep producing. This worker only costs us $100, but brought in $227. The 13th person brings in $119. We only had to pay that worker $100, so we're still making money. At 14, we're paying that worker $100, but they're only bringing in $17 of revenue. So we wouldn't hire that 14th worker. We would lose money when we look at our costs and our additional revenue, our marginal revenue from bringing that in. So this would be the level where we would produce, how many people we would hire, and the price that would be set.